Hello everyone, Geometry LR2, Unit 3, Lesson 1. Today our objectives are going to be to determine the relationship between a linear pair of angles and also the relationship between a pair of vertical angles. And then we're going to apply these to a number of diagrams. Let's get started. So here is an example of a linear pair. Okay, I want you to imagine, right, that angle. This angle right here, angle ACD. And this angle right here, angle BCD. They form what's called a linear pair because the two angles placed next to each other with no gap in between forms a line, hence the word linear in linear pair. So if two, and we could say or more, angles form a linear pair, or pairing, or grouping, then the measures of the angles add up to 180 degrees. This got all scrambled up over here. So we could say then that the measure of angle ACD plus the measure of angle BCD would add up to 180 degrees. Now, if two angles or more add up to 180 degrees, we say that they are supplementary. Supplementary. All right, that's a word that we'll see throughout this course. Okay, let's move on and consider this topic within the context of a diagram. Okay, so the linear pair conjecture says that if two angles form a linear pair, then the measure of the angles add up to 180 degrees. So what would our linear pairings be? Well, we could say that angle 2 and angle 3, that's a linear pair, as well as angle 1 and angle 2, and angle 1 and angle 4, as well as angle 3 and angle 4. So I have 1, 2, 3, 4 linear pairs within this diagram. Okay, let's see what that means for us on the next slide. Okay, now let's consider, before we get into this vertical angles conjecture, let's consider what we know about the measure of angle 2 plus the measure of angle 3. Well, since angle 2 and angle 3 are a linear pair, we know that those would have to add to 180 degrees. Let's also consider the fact that angle 3 and angle 4 are a linear pair. And therefore, if angle 3 and angle 2 add to 180, and angle 3 and angle 4 add to 180, then we could make the conjecture that angle 2, measure of angle 2, will be equal to the measure of angle 4. All right, so this brings us to the idea of vertical angles. If two angles are vertical angles, then they have the same measure. So in this example, angle 2 and angle 4 are vertical angles. They're across this vertex from each other. Therefore, they have the same measure. Likewise, angles 3 and angle 1 are a vertical pair, or vertical angles, and therefore their measures would be the same. Okay, let's continue with some relationships with angles. All right, we talked about supplementary angles. We said that supplementary angles, working on my spelling. Supplementary means two or more angles that add to 180 degrees. Two or more angles that add to 180 degrees. Complementary angles are two or more angles that add to 90 degrees. Okay, so you can see that angle 2 and angle 1 here would form a right angle. Okay, so examples of complementary angles might be 60 degrees and 30 degrees. All right, so the measure of angle 1 might be 60. Its complement would be the measure of angle 2, which would be 30. All right, let's continue with angle relationships on the next slide. Okay, nothing new on this slide. As you can see, supplementary angles are two angles that have a sum of 180. So if the measure of angle 1 was 45 degrees, then the measure of angle 2 would have to be 135 degrees, therefore forming a linear pair. Okay, as well as showing us that these would be supplementary. So we can see that two angles that are supplementary, or more for that matter, have a sum of 180 degrees. Okay, let's continue. All right, a special relationship that happens in triangles. And it's kind of cool how this works. But the three angles in a triangle. So if I were to draw this triangle without all the extra lines in here, I'd have angle 1 here, angle 2 here, angle 3 here. What actually happens is the measure of these three angles, angle 1 and angle 2 and angle 3, they actually also add up to 180 degrees. So if I were to take angle 1, right, I'm gonna label this angle 1 so that oh, and you know what? I can't move that, but I'm gonna try to do it here. Okay. I'm going to take angle 2 that looks like it's about a 90, and I'm going to put it right here. Okay, angle 2. Let's say it's 90, just for the sake of the problem. And I'm going to take angle 3, which is right here. I'm going to try to sketch it to the best of my ability, which I'll do it right here. There's angle 3. And then angle 1, if I were to turn it over, right, and insert it, it would kind of show itself to fit perfectly right there. So those three angles, what do they add up to? Well, they form a linear pair, actually a linear group, right, of 3. Look at that. They form a line. Therefore, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. And it doesn't matter what your triangle looks like. It could look like this. The three angles, A, B, and C in this triangle, their measures would add up to 180, regardless of what type of triangle it is. It could be a right triangle, isosceles triangle, equilateral triangle, scalene triangle. It doesn't matter. All three angles will sum up to 180, making those supplementary. Let's see what that looks like on the next slide. Okay, here I've got a diagram in this slide, and I'm given a little bit of information, and I'm going to use what I know about the three angles in a triangle being supplementary, about linear pair, about vertical angles, and all that good stuff, as well as the information given in the table here. So let's look at the measure of angle 4. Okay, the measure of angle 4, I'm told, right here. Let's mark this in a different color. Let's go red. That's 122 degrees. Okay, the measure of angle 7. Angle 7's measure is 97 degrees. The measure of angle 10 is 42 degrees. We'll mark that 42 degrees. Now let's look at what we know. Okay, we know that 1 and 10, given above, right here, 1 and 10 are complementary. What that means is that the measure of angle 1 plus the measure of angle 10, complementary means 90 degrees. Okay, so I know the measure of angle 10 is 42 degrees. So what I'm going to do is I'm going to solve for the measure of angle 1 by subtracting 42 from 90. Okay, and that gets me 48. So the measure of angle 1 should be 48 degrees. 48 degrees. Okay, outstanding. Now I'm kind of stumped. I can't really go to 2 or 3 yet. I mean, I can go to 3, but I can't go to 2 yet. So let's look at 3. What do you notice about angle 3 and angle 4? Well, they form a linear pair. So the measure of angle 3 plus the measure of angle 4 should equal 180. I know the measure of angle 4 is 122. So the measure of angle 3 plus 122 degrees gives me 180 degrees. So I subtract 122 degrees from 180 degrees, and I get angle 3's measure, which should be 58 degrees. Okay, 58 degrees. All right, let's move on and let's find the measure of angle 2. So as you look at the triangle that contains angles 1, 2, and 3, we know that the three angles have to add up to 180 degrees. So the measure of angle 2 plus the measure of angle 1, which is 48, plus the measure of angle 3, which is 58, again has to be supplementary, adding up to 180 degrees. So 48 and 58, if my math is right, should be 106 degrees. So the measure of angle 2 plus 106 degrees should equal 180 degrees. So the measure of angle 2 will end up being 74 degrees. Okay, let's move down toward angles 5, 6, 8, and 9. Okay, so as we look at angles 4 and 5, we can see that angles 4 and 5 are vertical angles. Okay, so those angles should be congruent in measure, therefore angle 5 should also be 122 degrees. Likewise, angle 3 and 6, those are vertical angles, so angle 6 will be 58 degrees, the same as angle 3. Okay, so angles 8 and 9. What we know about angles 8 and 9 is that they will add to 180. And now that I know angle 6 and 7, I can find the measure of angle 8. So 58 degrees, which is the measure of angle 6, plus 97 degrees, which is the measure of angle 7, plus the measure of angle 8, should come out to be 180 degrees. So I add 58 and 97, I get 155. And so I'm going to subtract 155 from 180, and that's going to give me 25 degrees. Okay, so if angle 8's measure is 25 degrees, okay, then the measure of angle 9 would be 180 minus 25 degrees, which would be 155 degrees. All right, so there you have it. That's how we use our properties of angles in order to solve a complex diagram like this one. Let's move on. We got a couple more slides. Okay, let's talk about what's called an if-then statement. And they have two parts. They have a hypothesis and a conclusion. So for example, if two angles form a linear pair, then the conclusion is that the measures of the angles add up to 180 degrees. Okay, now taking that if-then statement, we can also look at a different vocabulary term that we've talked about. If two angles are blank, then they have equal measures. So we would say that if two angles are vertical, and there's actually many things we could type in here or write in here at this point, but if they, based on our context of today's lesson, if they are vertical angles, then they have equal measures. Okay, if in the third if-then statement, if two angles sum to 90 degrees, I'll just put the degree symbol there, then they are called complementary angles. Complementary angles. All right, there's a few if-then statements. Let's look at what is called the converse. So let's take a look at the last slide for today, and then you'll have some time to work through your homework. Okay, so a converse switches the if and then parts of an if-then statement. Switch the hypothesis and conclusion. Write the converse of each new conjecture. So let's look at the first. If two angles form a linear pair, then the measures of the angles add up to 180 degrees. I'm reading right here. The converse of that would be if the measure of two angles add up to 180, then they form a linear pair. Now, this is not necessarily true. Not necessarily true. Let me draw you a diagram. If I had an angle over here, and an angle not forming a linear pair. Let's say the measure of this angle was 30 degrees, and the measure of this angle was 150 degrees. Those two angles, they may be supplementary, but they don't form a linear pair because they don't align themselves like this. So yes, I could have a linear pair if the two angles add to 180. Okay, and they are supplementary regardless, but they have to be in that formation. Okay, let's look at the second. If two angles are vertical angles, then they have equal measures. Conversely, if two angles have equal measures, then they are vertical angles. Okay, I'm going to abbreviate. Now, this also will follow suit, and I could say not necessarily because two angles could be congruent. Right? Here's one angle, let's say it's 28 degrees, and here's another angle, also 28 degrees. Are those vertical angles? Not necessarily, unless they follow the same formation like this. They share that vertex, and one ray, right, the ray of this angle passes through the vertex and becomes the ray of the opposite angle, likewise here. So it depends, right? Our converse depends on the orientation of the diagram. All right, guys, that's it for Unit 3, Lesson 1 on angle relationships. See you next video.